Okay, so hello everyone, my name is Jonathan Dortheimer, and it is my privilege to present you with the ongoing research project. I'm a postdoctoral fellow at the MTRL Lab, directed by Professor Aaron Sprecher, in collaboration with Professor Wendy Zhu from Cornell Tech. We started this project 3 months ago by forming an international research group from the US and Europe. While the COVID-19 pandemic affected our ability to travel, it facilitated digital communications in a way that makes such a global effort possible. The research is conducted in collaboration with Cornell Tech, Carnegie Mellon University, and Unix Technical University. I am presenting you this early research project to update you on the work that we do at the lab and initiate a discussion. Recent breakthrough in AI allow the research of automation in architectural design. However, architectural design is highly complex and dependent on the interaction and collaboration with clients and professionals. Our project aims to explore methods to integrate AI in a human design process. In this talk, I will first present the theoretical background and motivation to develop AI for architectural design. Then I shortly review the relevant AI capabilities. I will present our human-centered AI design model. Then the research method will be presented. And lastly, we will discuss research potential and outcomes and the preliminary results. So, how do we define AI? Russell and Norvig in the textbook define AI as the research field that is concerned mainly with developing machines capable of rational action, namely an ideal intelligent agent that takes the best possible action in a situation. As a counterpoint to Russell and Norvig's optimism, Kate Crawford is more critical. She argues that if AI systems are seen more reliable and rational than any human expert, able to take the best possible action, then it suggests that they should be trusted to make high-stakes decisions in health, education, and criminal justice. In this research, we are optimistic about the use of AI in design, but we are also cautious because there is no best action in design. People have long been fascinated by the idea that an inanimate object can become intelligent. The foundations of modern AI can be found in classical philosophy, which describes thinking as a symbolic system. Since the 1950s, research in AI is studying how machines can reason, represent knowledge, plan, learn, process natural language, perceive objects, and manipulate them. In my doctoral thesis, I developed an architectural design crowdsourcing software, framework, and process. I have demonstrated that architectural design could be produced using crowdsourcing based on professional architects and non-specialists. Coupled with AI methods, the algorithmic design process offers excellent potential to improve and automate architectural design. These computer abilities raise new questions about the place of human in an AI-based design process. Our project seeks new knowledge regarding human interaction with AI. The research will unfold through the following research question. What methods can provide an effective interface between humans and a generative AI in a design process? Now, we will go back in time to AI research that was concerned with finding scientific and computer methods of solving design problems. Then I will overview several new AI methods used to generate artifacts, specifically machine learning based on neural networks. Following the Design Methods Conference held in 1962, there has been a broad consensus amongst scholars that the systemic design process consists of 3 steps. The analysis step includes collecting, classifying, mapping the relationships between factors, articulating the problem specifications, and reaching an agreement. In the synthesis step, creative thinking is applied to create partial solutions. And finally, in the evaluation step, the solution is judged by various evaluation methods. However, in practice, the design process has interdependency links between decisions. After changes are made to the design elements, previous decisions must be re-evaluated. For example, changing external walls would also require changing the roof. This will lead to more changes in the design in a circular manner. Based on these findings, T.A. Marcus added one more level to the design process. This higher level consisted of the following 3 components: preliminary, sketch, and detailed design. This approach is the foundation of RIBA plan of work that is the most accepted design process in architecture. In his book, The Science of the Artificial, Herbert Simon introduced the idea that design is a search process in a solution space. Also, he argued that design is a challenging problem from a computer science perspective, since the designer does not have all the required information to create an optimal solution. Additionally, sometimes design requirements conflict. Therefore, design problems are considered wicked problems and ill-defined. Design solutions are not absolute and correct, but an optimized compromise that is a good fit. Extending the notion that design is an exploration of the solution space, I developed an algorithmic design method. This method relies on crowdsourcing, which provides a community with the ability to produce designs together with experts. The design process is based on RIBA's approach, but instead of structuring it around the cognitive process of the designer, it regards a human as a black box that receives input and produces output. The design process starts with an input of a brief, here in the red. Then the brief is explored through design, resulting in a variety of artifacts for many architects. In the selection process, the community chooses the best designs. Finally, in the review phase, feedback is provided. This is critical information that is essential for the next iteration and also updates the problem space. The final design is a product of the wisdom of the crowds and a collective intelligence that emerges due to the collaboration. For the current project, we will extend this model by integrating AI components into it. Today, we are fascinated by artificial neural networks that are capable of machine learning. A neural network is a computer system inspired by the biological neural network found in brains. They are made out of neurons, which are organized in layers, and the layers are connected. In this example, we have an image classification neural network. It was trained to identify cats or dogs. There is an input layer that receives an image. There are 2 neurons on the output layer. One that outputs the chances that there is a cat in the image, and the other, the possibility of a dog. Although such a neural network is relatively simple, they require a large labeled data set of cat and dog photos. To create this data set, human labor is needed, which is extremely expensive. The introduction of generative adversarial networks, called also GANs, by Goodfellow and colleagues, allowed generative neural networks to be trained by small data sets. Using different approaches, researchers have created some exciting new methods of creating architectural designs. A GAN is made out of 2 neural networks contesting with each other in a zero-sum game. For example, Jones and Bonafila created Gun Growth. Here, that's the example of Gun Growth, a gun that produces fake Van Gogh pictures. Similarly, it is possible to make architectural images. This is another kind of gun. Style gun is a neural network that learns to identify. Style gun is a neural network that learns to identify an image style and apply it on other images. In this example, human face style is applied to different human faces, creating faces of people who do not exist. Another gun approach is pix-to-pix. This is a conditional gun that is trained for a specific task. For example, building images, we can see here an example, were classified into architectural elements, and the network was trained to generate building images from the architectural layout. Let's see an example. So we get a random layout. We can change the layout. For example, we add a larger door. We click process and the image is updating with a larger door. Now we try to add some striped windows in modern style. Let's see what it creates. Then we get this classic facade with longer windows. Now I'm adding a background. So in this situation, the network produces a distorted image, and it is rather disappointing. So human designers use natural language to analyze the problem space and evaluate designs by discussing them. After gaining an understanding, the designers produce solutions and express them using sketches and natural language. Following this notion, OpenAI introduced an adaptive image generation AI model called DALL-E that uses transformer deep learning approach to convert natural language into images. DALL-E is capable of combining unrelated concepts in a plausible way that is creative. For example, a photo of a computer from 1910s produced novel computer designs. You may see more examples in the video, like a street in Israel, a storefront with specific text on it, even more complex examples like a living room having two olive armchairs with a painting of a windmill. The painting is mounted over a traditional fireplace. DALL-E is remarkable as an AI that can convert natural language into images in a way that makes sense and is also creative. We can see TVs from the 19th century. So I want to ask you, is this similar to design work? Can a client express a design problem in natural language, and the designer who understands the situation produces multiple sketches of novel artifacts? So we started developing an AI model that produces architectural sketches. We chose TensorFlow's deep convolutional generative adversarial network. We trained the GAN based on a training set made out of architectural sketches, and you can see now the sketches that we used. The set included images of sketches that depict buildings rendered using pencils and pens. We also classified them by elevations, sections, plans, and perspectives. And you can see now the training set of perspectives. We trained our model running our code. Every learning iteration produced 25 images that were saved for documentation. Here we can see the learning process by combining all 15,000 images into a 1-minute video. we can see that the model tries to produce architectural sketches. It slowly adapts and discovers architectural geometric features. So I think this part of the learning is the most interesting because the images are rather abstract. And to the end, we will see that it tries to actually guess the images from the training set. But a second before it guesses the images, it is very, I think this is the interesting part. So here we get images that are similar to the training set. The trained model produced several new architectural images based on the different training sets. However, we had little control over the design. Also, with this method, the design was not related to the design requirements. The set images suggesting that the results were overfitting. Together with conclusions from the literature review, we found that generative AI is limited. First, it is a statistical function to produce fake artifacts. A useful method must be coupled with design logic. Second, the interaction did not seem intelligent to us. A phenomenon called AI effect explains this. Challenges like text recognition or the understanding of spoken language that in the past were considered AI are nowadays not perceived as AI anymore. Our perception of an intelligent computer is dynamic and changes with progress. In science fiction movies like Metropolis, AI has the body of a robot as an interface. Although we have cool robots in the lab, we are interested in the essence of the intelligent experience, a conversational interface. It seems that in order for a computer system to appear intelligent in movies, it must communicate with natural language. This approach is wonderfully expressed in the 2013 movie Her by Spike Jonze. In the movie, the protagonist develops a relationship with Samantha, an AI virtual assistant, through conversation. While general AI, like Samantha, is not our goal, we believe that exploring AI through conversation is essential. We argue that conversational AI could be introduced as a component of a human-centered AI design process. To explore how AI can integrate as a collaborator in the design process, we use the crowdsourcing design model. We extend the crowdsourcing design process model and integrate AI into the design process by placing AI components as an interface between clients and designers to improve the process. In our case, one could think of an AI as a helper or communicator of the design. The first step is to define the problem space. A brief could be derived from a conversation using natural language processing and a chatbot. In the next phase, designers use AI to generate partial design recommendations. With more advanced AI, autonomous generators could produce designs alongside of humans. Selection is a straightforward but critical task. During this phase, humans select the best designs. Finally, humans are asked to review the design. This phase is critical for a collaborative design process. Here, we suggest using NLP with a chatbot interface to perform design review conversation. We are currently concentrating on the first step, the design conversation, the collection of requirements, and modeling of the design space, the problem space, sorry. Our current goal is to build a design chatbot. To learn how people discuss a design with an AI, we use the Wizard of Oz research method. The idea underlying the Wizard of Oz method is that the human operator is behind the scenes of a operates behind the scenes of a sophisticated machine in a way that an observer may assume that it is automatic and mechanical. In this way, we can learn how people react, converse with a chatbot without building a working prototype. We started to talk with people about their dream house while recording their reactions. On this screen, the wizard acts as the AI. It has some predefined questions and responses. The "I'm sorry, but I didn't understand what you said" message is our favorite. In the lock screen, we can see the conversation and the subject reaction. Based on the insights and knowledge from the experiments, we will model a conversational chatbot using a commercial chatbot platform and GPT-3. GPT-3 is the world-leading natural language model. So to summarize, with the development of advanced AI, digital design techniques that use these methods are becoming increasingly popular. This research will provide valuable insights into how AI could be used with humans in a design process.